this law of motion, the first law of motion is also called, because of this, inertia is related with first law of motion. That means the tendency to tendency to resist change is there for everybody, and the applying force is more than the tendency, more than inertia. Then only what will happen? Motion will happen. So this first law of motion can also be called as law of inertia. Okay, so whenever you are hearing that, whenever you are asked to write law of inertia, whenever you are asked to say what is law of inertia, don't worry about anything. It is just first law of motion. It's another name of first law of motion, because in first law of motion we are discussing the term inertia. Okay, so first law of motion is also called as law of inertia. And what is law of inertia, or what is first law of motion? Any object will remain in its state of rest or of uniform motion in a straight line unless it is acted upon by an external unbalanced force. Clear? Okay, so that is first law of motion. We have discussed the first law of motion and law of inertia. Isn't it easy? Okay, is there any confusion regarding this thing? Okay, so when you are writing on your notes, you will be studying it more clearly, and you will be having a lot of examples also. So don't worry about it. I hope the concept is clear. Okay, now we are moving on to the next law of motion, that is second law of motion. We are moving on to the second law of motion. So before studying second law of motion, we have to study a new term called momentum. A new term called momentum. Okay, you might not have heard anything about this momentum, but don't worry about it. I will be making it more clear to you. Momentum means, leave momentum. Just you recall what is mass. You know what is mass? The weight of any body. Okay, the mass or the weight. It is the mass of. Will be discussing it more clearly. Is mass and weight same? No. Mass and weight is entirely different. Entirely different in the sense they are having two different scenarios. But okay, mass and weight, it is a measurement of weight. Weighing measurement is called mass and weight. Okay, whatever it is, we will be studying the differences, the difference between mass and weight. There is a huge difference between mass and weight, and that we will be studying it in the next chapter, that is gravitation. So don't worry. Mass means it is, what is my mass? It is 70 kilogram or 80 kilogram. Or what is the mass of a cricket ball? It will be 15 gram or 1.3 kilogram. Like, okay, so whatever, mass, the weight of any body, mass. And you have also studied what is velocity. Isn't it? We have studied what is velocity. So listen, a car is moving. The car will be having around 700 to what will be the weight, what will be the kilo? It will be having around 500 or whatever it is. Consider it is having 500 kilogram weight, the car. And it is moving with a velocity of 60 meter per second or 60 kilometer per hour. Okay, the car is moving at 60 kilometer per hour. You can note the speed of the car in the speedometer. Inside there will be digital speedometer or the manual speedometer, whatever it is. The speedometer, you will be having the velocity of the car, and the car will be weighing it will be having around 500 kilogram. The velocity will be 60 kilometer per hour. Okay, and let it be in SI unit. The SI unit of weight or mass is in gram. SI unit is kilogram, and SI unit of velocity is meter per second. The SI unit of velocity is meter per second. Okay, so you know the mass of the car and you know the velocity with which it is moving. And what is then momentum? Momentum is nothing but it is the product of mass into velocity. Momentum is nothing but it is the product of mass into velocity. The product of mass into velocity will give you what? Will give you what? Momentum, and it is denoted by the letter P. It is denoted by the letter P. Momentum is denoted by the letter P. So P is equal to mass into velocity. P is equal to mass into velocity. So don't worry about this new term. It is just the product of two terms which we already know, that is mass and velocity. The product of two terms, mass and velocity, will give you a new term called momentum. Okay, so momentum is denoted by the letter P, and it is the product of mass into velocity. And what is the SI unit? What is the SI unit? The SI unit of mass is kilogram. The SI unit of velocity is meter per second, isn't it? So the SI unit of momentum is kilogram into meter per second. That's equal to kilogram meter second raised to minus 1. Meter divided by second, meter second raised to minus 1. So that is the SI unit of momentum. So momentum is just the product of mass into velocity. It is just the product of mass into velocity. Is that clear? Keep it in mind. Understand it carefully. Study the equation. Momentum is the product of mass into velocity. Clear? Is that clear? Okay. So that is okay. So now we will be studying the second law of motion. Now we will be studying, or we will be discussing the second law of motion. Okay. So the second law of motion, I will write it for you. The rate of change of momentum, the rate of change of momentum, the rate of change of momentum of an object, the rate of change of momentum of an object is directly proportional to the applied force. Again it is related with force. Directly proportional to the applied force. Okay, and also in the direction of motion. In the direction of application of force. What it is? The rate of change of momentum. Rate of change of momentum. What did I tell you? Rate of change of acceleration. What was acceleration? Rate of change of velocity. Acceleration was rate of change of velocity. So what it was? I have told you in the last class, in the last chapter, whenever the term rate of comes, whenever the term rate comes, rate of in physics, whenever the term rate of change of something, whenever it comes, it is related with what? It is related with what? Time. Here the rate of change of something means it is something is changing with respect to time. Something is changing with respect to time. That is what you have to understand whenever you are studying. That is what you have to understand whenever you hear the term rate of change of something. Okay, here, so what is happening here? Here something is changing. What is changing? Momentum is changing. Momentum is changing with respect to time. Momentum is changing with respect to time. That means when will the momentum change? Rate of change of momentum of any object is directly proportional to the applied force. So what is the second law states? What does it say? It just says that the second law of motion states that the change in momentum with time will happen if force is applied. Force is required for the change of momentum to happen with respect to time. Okay, and how much force we apply, that much momentum will change. Understand like this. In car, the driver will apply force on the accelerator pedal. Okay, so as he applies force, the car will move at a higher speed. If he releases the force applied on the acceleration pedal, the car will slows down. If he again push the accelerated pedal, if we again apply more force on the accelerator pedal, the car will move again at a high speed. Okay, so how much force is applied, that much rate of change of momentum. That means in car, I have told you, mass will be there for car and the body will be moving with a velocity, so it will be having some momentum. That means whichever body is in motion, it will have what? Momentum, because that body will be having some mass and the body will be, whenever it is moving, it will be having velocity. So mass into velocity, whichever body at motion, any object at motion will have momentum. Any object at motion will have momentum. Important thing. Any object at motion, it will be having momentum. Clear? Okay. So, and the change in momentum, if the momentum changes, how will the momentum change? The rate of change of momentum, the change in momentum with the time will happen with respect to the application of force. How we are applying force, like that only the momentum will also change. As and how we apply force. If we apply more force, more will be the change in momentum. If we apply less force, the momentum will reduce. If we apply more force, again it will increase. Then if we reduces the application of force, it will decrease. So that is the concept which you have to understand in second law of motion. That means rate of change of momentum. Rate of change of momentum of an object is directly proportional to the applied force in the direction of application of force. That means if I am pushing this table forward, I am applying force on this table forward. So the momentum will change in the forward direction itself. If I am pulling this table backwards towards me, then I am applying force to this direction, to the backward direction, then the momentum will change in the backward direction. So rate of change of momentum, that means, for example, when the car was moving, it was moving with a velocity u, initial velocity u, it was moving with an initial velocity u, let it be, or let it be moving with an initial velocity 50 meter per second. Okay, and then it increases, the driver applied more force, the speed increased to 80 meter per second in 15 seconds. Okay, in 15 seconds. So then what will be the change in momentum, rate of change of momentum? Rate of change of momentum means the final momentum minus initial momentum divided by time. This is rate of change of momentum. What you have studied? Acceleration. Acceleration means it is rate of change of velocity, final velocity minus initial velocity divided by time. This was rate of change of velocity, and that is acceleration. Here final momentum minus initial momentum divided by time will give you rate of change of momentum. And so here what will it be? 80 minus 50 divided by 15. The rate of change of momentum here is 80 minus 50 divided by 15. That means 30 divided by 15. That is 2 kilogram meter per second. So here the rate of change of momentum is 2 kilogram meter per second. So a body was moving with 50 meter per second, then it increased to 80 meter per second. Okay, so and also no, we can't take it like this. Here there is what, P2 minus P1. So okay, I'll discuss it. P2 minus P1. Here it was moving with 50 meter per second to 80 meter per second. It increased, the velocity increased to 80 meter per second in 15 seconds, and the weight of that car can be 100 kilogram. Let the weight of that car be 100 kilogram. So what will be change in velocity? The initial momentum will be 100 into 50, that is 5000 kilogram meter per second. The final momentum will be 100 into 80, that's equal to 8000 kilogram meter per second. So what will be rate of change of momentum? That means P2 minus P1 divided by time, that's equal to 8000 minus 5000 divided by 15. Time is 15, I have told you. Okay, so that's equal to 8000 minus 5000. So that will be 3000 divided by 15, that's equal to how much? 200 kilogram meter per second. So here the rate of change of momentum is, in this scenario, the rate of change of momentum is 200 kilogram meter per second. Okay, so this is how we have to understand the rate of change of momentum. Okay, so this is just an example. I have just said this because you just want to get a good idea about what is rate of change of momentum, how the rate of change of momentum happens. So whenever the term rate comes, you have to understand that it is related with time. It is related with time. Here the change of momentum with the time is directly linked with the application of force. It's directly linked. I have told you, if we apply more force, the momentum will increase more. If we apply less force, it will decrease. The momentum will decrease. So the change in momentum is directly linked with the application of force. This is what we have to understand by the term second law of motion. Clear? I hope it's clear.